Hello, I am Sunita. Welcome to my class. Here I am going to discuss Gpstr science topics according to syllabus. Here the topic is the fundamental forces in nature. This topic is very important. Let us study the topic. The fundamental forces in nature. The fundamental forces in nature. There are four universal or fundamental forces in nature. Without these forces, all matter in the world will fall apart. Assume if you don't have any fundamental force in nature, then all matter in the world, they will not either attract, they will not repel, even they will not experience any force. Therefore, all the matter in the universe, they will be apart from each other. Force such as any pull or push that cause an object to alter its physical state in terms of motion or deformity. If the force involve any push or pull, then it can change its physical state of an object. Then next one, according to Newton defined a force as anything that causes an object of mass m move with an acceleration a. According to Newton, what is meant by a force? Force is nothing but if an object is having mass m, if you apply a force, then that object is moves with an acceleration a, then that one we will call it as a force, otherwise we applied force. Following are the four fundamental forces in nature. First one is gravitational force, second one is electromagnetic force, the third one is strong nuclear force, fourth one is weak nuclear force. Let us discuss in detail the fundamental forces in nature. Gravitational force, it is the force of mutual attraction between any two objects by virtue of their masses. The force of attraction between any two objects because of their masses, this force we will call it as a gravitational force. It is a universal force as every object experiences this force due to every other object in the universe. According to gravitational force, whether the object is small or big, every object in the universe, they will be attracted by each other. Here, falling apple from apple tree, this is also an example of a gravitational force. Then the planets revolve around the sun, this is also one of the example of a gravitational force. Gravitational force formula. Gravitational force can be represented as follows. Fg, it will represent a gravitational force. It will be equal to capital G m1 m2 divided by r square. Here capital G represent universal gravitational constant. Then m1 m2 or the masses of the object is consideration. Then r is the distance between the center of the two object is in consideration. Here gravitational force is directly proportional to the product of mass of an object. Then gravitational force is inversely proportional to the square of the distance between the object. This point also you have to remember. Gravitational force of Earth. Gravitational force of Earth is 9.807 meter per second square. Let us discuss gravitational force examples. First one, the revolving of the moon around the earth is due to gravitational attraction between them. Even and earth and moon, they will attract each other, then there will exist a gravitational force. Then therefore the revolution of moon around the earth, it will involve a gravitational force. Next one, the formation of tides in the ocean is due to the gravitational force acting between the earth and the moon. The formation of the tides in the ocean, then it will exist because of the gravitational force or gravitational attraction between the earth and the moon. Gravity governs the motion of the moon. Then artificial satellites around the earth. You know, artificial satellites also, they will move around the earth. This also because of the gravitational force exist between artificial satellite and the earth. The motion of the earth and other planets around the sun, even the motion of the earth and other planets revolving around the sun, this also example of a gravitational force. Gravity governs the motion of bodies falling to the earth. If you throw any object above the earth, maybe ball or apple, anything, then that earth, it will attract the bodies, all the bodies, otherwise all the object, they will falling to the earth. This is also example of a gravitational force. Gravitational force play a key role in the large-scale phenomena of the universe such as formation and evolution of stars. Even the formation evolution of stars, it will involve a gravitational force. Galaxies and galactic cluster, this also an example of a gravitational force. Electromagnetic force, it is the force between the charged particles. Electromagnetic force, it will occurs between the charged particles. Charges at rest have electric attraction between unlike charges and repulsion between the like charges. Here, like charges mean positive, positive. They will repel each other. Here also like charges negative, negative. They will be repel each other. Then unlike charges like positive, negative, they will be attracting each other. When the charges, when they will be in motion, they will produce a magnetic force. Together, they will be called as a electromagnetic forces. Let us consider this picture. A current carrying wire generates a magnetic field around it, gives rise to a electromagnetism. Electromagnetic force. First one, the electromagnetic force is the force between the charged particle. The electromagnetic force, it will exist between the charged particles. Second one, in the simpler case when charged particles at rest, this force is given by Coulomb's law. When the charged particles, when they will be at rest, then the force of attraction between the charged particle is given by Coulomb's law. Third one, Coulomb force between charged particles is attractive for unlike charges and repulsive for like charges. According to Coulomb force, like charges, they will be repel each other, unlike charges, they will be attracting each other. Fourth one, the charges in motion produces a magnetic field. When the charge, when they will be in motion, they will produce a magnetic field. The magnetic field give rise to a force on a moving charge. The magnetic field, it will give rise to a force on a moving charge. This force is also an electromagnetic force. This force we will call it as an electromagnetic force. In general, next one, electric and magnetic effects are inseparable. Hence the name electromagnetic force. We can't separate electric and magnetic field. We can't separate them. Therefore, the name is given by electromagnetic force. Next one, like the gravitational force, electromagnetic force act over larger distance, does not need any intervening medium. Like a gravitational force, even electromagnetic force, it will exist even a large distance also. Then it does not need any medium for interaction. Then last one, the range of electromagnetic force is infinite. We can't find the range. Here, the electromagnetic force of attraction or repulsion between the object, it will be infinite. We can't measure the force between an object. Let us discuss the major difference between gravitational force and electromagnetic force. Gravitational force is always attractive, while electromagnetic force can be attractive or repulsive. You know, gravitational force is exist between the two bodies of having different masses. Always the gravitational force is attractive force, while an electromagnetic force, it will exist between the charged particles. Like charges, they will be repel each other. Unlike charges, they will be attract each other. Therefore, electromagnetic force, it will involve both attractive and repulsive force. Then next one, gravitational force act between the two masses, and the masses come in only one variety. There is no negative mass. You know, gravitational force, it will exist between the two bodies of different masses. In masses, we will not find any negative mass, but charge responsible for the electromagnetic force come in two varieties. One is positive and negative charge. But in the case of an electromagnetic force, it will involve a charged bodies. One body is positive charge, another one may be negative charge. Therefore, the force of attraction between the charged bodies, it will come to lead an electromagnetic force. Since matter is mostly electrically neutral, you know all the matter in the universe is electrically neutral. Net charge of the matter is zero. Thus, an electric force is largely zero. Therefore, in the universe, electric charge is almost zero, is not manifested in nature, so that the gravitational force dominate in terrestrial phenomenon. Compared to electromagnetic force, gravitational force, it will exist in terrestrial phenomenon. It will exist in more in nature compared to electromagnetic force. In other words, you can see, find out in the universe, gravitational force is more compared to an electromagnetic force, because all the objects, they will be not involved any charged bodies. Net charge in an object, otherwise in the body, maybe sometime it may be zero. Therefore, gravitational force, it will exist in terrestrial phenomenon. The next one, the electric force is generally 1036 times stronger than the gravitational force. Electromagnetic force is stronger than the gravitational force. How much stronger? 1036 times stronger than the gravitational force. Let us discuss third fundamental forces. Third one is strong nuclear force. According to Bohr model, nucleus is made up of a proton and neutrons. Then electrons, it will be revolving around the nucleus. Then it is the attractive force between the proton and neutrons in a nucleus. Therefore, strong nuclear force is nothing but a force of attraction exists between a proton and a neutron. It is a charge independent and acts equally between a proton, they contain same charge, they will repel each other. Neutron also, they will contain same charge. Therefore, here also you can see repulsive force. A proton and a neutron contains opposite charge, they will be attractive in nature. But in the case of a strong nuclear force, it will exist between the attraction force between the proton and neutron. Recently discovered that proton and neutrons are built up of an elementary particles called as a quarks. Let us discuss more about strong nuclear force. First one, the strong nuclear force is attractive in nature. You know, the nucleus, it contains both proton and neutrons. Then here the nuclear force, it will involve the attraction between the proton and neutron. Therefore, strong nuclear force is a attractive force. Second one, the strong nuclear force binds proton and neutrons in a nucleus. Because of this strong nuclear force, proton and neutrons, it will be held in a nucleus. This attractive force is responsible to hold the proton in nucleus against the electric repulsion between them. You know, proton like charges, they will be repel each other. Neutron like charges, they will also repel each other. Proton, neutron, they will be attract each other. Because of this strong nuclear force, even proton, neutron, all the proton and neutron held together in a nucleus because of this strong nuclear force, even though they will exhibit repulsive force. In other words, we can say that this force is responsible for the stability of the nuclei. This strong nuclear force, it will decide the stability of the nuclei. It will responsible for the stability of the nuclei. Third one, the strong nuclear force is the strongest in all the fundamental forces. Strong nuclear force, this is the strongest force in all the three fundamental forces. It is about 100 times stronger than the electromagnetic force, 1039 stronger than the gravitational force, then 1013 times than the weak nuclear force. Therefore, stronger nuclear force is the strongest force among the remaining fundamental forces. Then next one, fourth one, strong nuclear forces is a charge independent force. It acts equally between a proton and a proton, a neutron and a neutron, and also a proton and a neutron. You know, the nucleus, it contains a proton and neutron. This strong nuclear force is a charge independent. It will not involve either a positive and negative charge. You know, like charges they will be repel each other, unlike charges they will be attract each other. But this strong nuclear force it will be same for like charges also, it will be same for unlike charges also. Therefore, it will act equally between this strong nuclear force is same between the proton and a proton, and a neutron and a neutron, even and a proton and also a neutron. It will exist a equal strong nuclear force. Therefore, strong nuclear force is a charge independent force. It does not depend upon the charges. The next one, its range is extremely small of about nuclear dimensions 10 to 15 meter. The range of an strong nuclear force is very small. It's about 10 to 15 meters. Since the range of this force is very small, so that the electron does not experience this force, this strong nuclear force, it will exist in a small range. Therefore, this strong nuclear force, even the electrons, they can't experience this force. Even the range of this strong nuclear force is very, very small. Let us discuss fourth fundamental force in nature, weak nuclear force. This force appears only in certain nuclear processes such as beta decay of a nucleus. When beta decay of a nucleus, if it takes place, then you can observe weak nuclear force. In beta decay, what is meant by beta decay? In beta decay, the nucleus emits a proton, then uncharged particles called neutrino. These particles were first predicted by Wolfgang Pauli in 1931. This weak nuclear force it will exist in beta decay of a nucleus. In this beta decay, it will emit an electron and uncharged particles called neutrino. This is very, very important. Weak nuclear force. Here you can observe hydrogen. If it is involved beta decay of a nucleus, then it will give helium. Weak nuclear force. This weak nuclear force appears only in certain nuclear processes such as beta decay of a nucleus. When this beta decay happens, in beta decay, the nucleus it will emit an electron, then uncharged particles called neutrino. The weak nuclear force is not as weak as the gravitational force, but much weaker than the strong nuclear and electromagnetic force. This weak nuclear force is not weaker than gravitational force, means it is stronger than the gravitational force, but this weak nuclear force is weaker than the strong nuclear force and electromagnetic force. Table of fundamental forces in nature. Name: gravitational force. Relative strength is 10 to the power of minus 39. Range: infinity. You can observe gravitational force up to infinity. Then this gravitational force, all the objects in the universe, gravitational force is the attractive force. It will exist between the all the objects in the universe. Second one, weak nuclear force. Relative strength 10 to the power of minus 13. Range, very short subnuclear size 10 to the power of minus 16 meter. You can observe weak nuclear force. It will exist. It will release some beta decay particles. Then it will emit electrons and some neutrons, and it operates among some elementary particles, particularly electron and neutron. Already I told this weak nuclear force it will produce when beta decay it will happens. This beta decay it will involve the emission of electron and also neutrino. Then third one, electromagnetic force 10 to the power of minus 2 relative strength. Then this range also it will be infinity. This electromagnetic force it will exist between only charged particles. The next one, strong nuclear force, relative strength is 1. Range it will be shorter, nuclear size 10 to the power of minus 19 meter. Strong nuclear force is it will exist between the nucleons. Nucleons is nothing but protons and neutrons, heavier elementary particles. You can see in this a strong nuclear force in heavier elementary particles. Thanks for listening my class. Send me your valuable feedback. The topic discussed here is very important topic. This topic they will ask in descriptive type questions. Therefore, you have to understand the concept. Once you understand the concept, then you can write in the exam very easily. Then it will help to clear your Gpstr exam.